So hello students, in this video let's discuss regarding one of the algorithm, that is non-additive join property. So in relational decomposition, so if you decompose the relation into multiple relations, so now after that once again if you are join those relations, so that joining what are the informations you will get know, so that information must be non-additive. So non-additive join property or lossless join information actually we call. So how we'll check that one? So for checking that, one of the algorithm is available, that is testing for non-additive join property. For this algorithm, inputs are a universal relation R. That relation is decomposed into R1, R2, Rm, that is denoted as a T. T contains the decomposed relations of R and set of functional dependencies F. So now our aim is what? Now we have to check that this decomposed relations have the non-additive join property or not, or lossless join property or not here. Okay. So to check that, in this algorithm, first you have to create an initial matrix X with one row I for each relation Ri in D. So for example here R1. So for one R1 one row you have to create, for R2 one row you have to create, like that. How many relations are there in this decomposition? All those, for all those relations you have to create a one row here and one column J for each attribute Aj in R. So in R, how many attributes are there? So in this R, how many attributes are there? For each attribute, one column you have to consider. This is your first step. You have to create a new matrix. Rows are number of relations and columns are number of attributes in that relation. Next is you have to set each values of that particular matrix is I of j equal to b of ij for all matrix entries. So that is the row number and the column number. I indicates row number and j indicates the column number. So now initial matrix values you have to set as a b of ij here. Next, for each row I representing relation schema Ri. So in the Ri, so each row, that one you are representing like as a Ri. For each column J representing attribute Aj. So row is the relation schema and column is actually attributes. So that attribute you are denoting like as a Aj and row you are representing as a Ri. So if relation Ri includes attribute Aj. So now in the R1 relation, so that attribute if it is included, then set S of ij value as a aj. Okay, so j indicates what here? Column and I indicates row. So now earlier you initialized all the values of the attributes as a b of ij. I is row and j is column. So now in that particular row, so if in the R1 that attribute if it is there, so then that attribute value you have to set as a and you have to represent only the column number here. Okay. Next is step 4. Repeat the following loop until a complete loop execution results changes to S here. So this procedure you have to repeat until the values of the matrix will be changes here. So for each functional dependency, X determines Y in F, because the input you are having the set of functional dependencies also. So for each functional dependency, now you have to consider the functional dependencies in F for all rows in S that have the same symbols in the columns corresponding to attributes in X. So for in rows, so multiple rows for the X value if it is same, then if Y value if it is same or not, you have to check here. So that is what we call as a all rows in S have the same symbols in the column corresponding to attributes in X. If it is not, then make the symbols in each column that corresponds to an attribute in Y be the same in all these rows as follows. You have to change the rows according to this condition. What is that? If any of the rows has an A symbol for the column, if you are having the A symbol, set the other rows to that same symbol in the column. So other rows also you have to set as a that symbol only, because you already know that what is functional dependency definition tells. In two tuples x value if it is same, then y value must be same here. So now you already have the functional dependency. Meaning of that one is what? That must be compulsory same here. So that's why you are changing according to that definition only. You are changing the a symbol in the column. If a no symbol, okay, if no a symbol exists for the attribute in any of the rows. So if a symbol is not exist, then choose one of the b symbol that appears in one of the rows for the attribute and set the other rows to the same b symbol in the column. Either you set as a symbol or you can set as a b symbol, and this one you have to repeat for all functional dependencies. So like this you have to change the columns value either as a or as a b symbol here. It is depends on what? Based on your functional dependency. After changing the rows, next step you have to check whether it is row is made up of entirely A symbols. If any one row contains the values of A symbols, then the decomposition has the non-additive or lossless join property. If any one row contains the same A symbols, then it is the lossless or non-additive join property. If it is not, then it is a additive join property. It does not having this property here. Non-additive join property is not preserved if the symbol is not there here. So this is the algorithm which is used to check the non-additive join property. Let's see same thing using one example. Here I taken the example relation R. So R contains the attributes are SSN, ename, pnumber, pname, plocation and hours. And this R relation is decomposed as R1 and R2. D contains R1 and R2 here. So R1 is renamed as a EMP LOCS, and attributes of R1 are ename and plocation, and attributes of R2 are SSN, pnumber, hours, pname and plocation. This R is decomposed as a R1 and R2, and attributes of R1 and R2 are here. Next, given functional dependency for this R is F equal to SSN determines ename, pnumber determines pname and plocation, and combination of SSN pnumber determines hours here. So now our aim is what? I need to check that whether it is having the non-additive join property or not. So for that, what is the step 1 tells? You have to create a new matrix. So that matrix rows must be what it is? Relation. So how many relations you are having? R1 and R2. So then in the table how many rows you require? 2 rows, R1 and R2. Here I taken R1 as a first row, R2 as a second row here. And J indicates what it is? Attributes of R. So in the R, what are the attributes you are having? Those are attributes you have to consider as each column here. So SSN is the first column, ename is the second column, pnumber, pname, plocation and hours. So now these are columns are what now? These are the attributes now. After that you have to initialize this matrix. So for initializing, what is the procedure? You have to take S of ij equal to B of ij. I is row and j is column here. So B, this is your first row and the first column. So in the same way, ename, I already changed this one. One step you have to take this one as a first row, second column, first row, third column, first row, fourth column, first row, fifth column, first row, sixth column, okay, and second row, first column, second row, second column, second row, third column. Like this you have to initialize first. After initializing, next you have to check the attributes of the relation. So in the R1, attributes are what now? Ename and plocation. So in R1, now what are the attributes are there? So those attributes values you have to change. Okay, instead of taking as a B, now you have to take as a of J. So now J means what? It will just take the column name. So ename is the attribute of R1. That's why you have to take as a symbol, and this is your second column. And next attribute of R1 is plocation. So that plocation is what? Now you have to rename as a and this is your fifth column here. In the same way, in the R2, what are the attributes are there? those attributes you have to rename as a AJ here. SSN is here, so S, A, first column, and P number, A, third column, hours, okay, where it is A, sixth column, P name, A, fourth column, P location, A, fifth column. So while changing the A to, that is B to A, so in the B, while initialization, you are taking rows and column numbers. So based on the number of attributes in those relation, you renamed or you are changed that value as a new value. You are set it as a new value A, as a new symbol A, and now here you are considering only the symbol here. Okay, this is your next step. After considering this one, next step is you have to consider the functional dependency. SSN determines E name. So now here SSN is what it is. This is having the A name and E name. In two tuples, SSN value if it is same, then this E name value also you have to change, but here it is not the criteria because here SSN is different. Okay, that's why E name is also different here. In the same way, next functional dependency is P number determines P name and P location. In two tuples, P number value if it is same, then you can change the P name and the P location value also. But in P number, these values are different here. Here you are in A3 and B3. So that's why modification of this one is also not necessary. And in two tuples, SSN and P number if it is same, then you have to change the hours also. But according to this functional dependency, no modification is applied for this particular matrix here. So after, according to functional dependency, if changes are there, then you have to change, otherwise you leave as it is. After completing this one, next you have to check whether it is the non-additive joint property or not based on the symbols. So in any one row, if all the symbols are A, then you call that one as a non-additive joint property. So in the row 1, is it all the symbols are A now? No, it is containing the combination of B and A. Next, in the second row, is it all the rows are okay? So all the values are the same here. Is it contain symbol A? No, the second column contains the symbol B here. So in both the rows, it doesn't contain the same symbol A or same symbol B here. So that's why, so this decomposition tells what it is. It is the additive joint property here. So lossy join it is. So because that criteria is not fulfilled here. So that's why this example tells what it is. It is a additive. It is not fulfilled the criteria. That's why it is not a non-additive joint property here. So in this way, once again I taken the one more example. So if I combine, okay, if I combine these two relation once again back, I won't get the same information back here. I can get the additional information, I can lose the sum of the information here. So that's why this one is not preserved in this example. So in the same way, I have taken one more example. That same relation are SSN, E name, P number, P name, P location and hours. So instead of decomposing as a 2 relation, I decomposed that relation as a 3. R1, R2, R3. So T is, contains R1, R2, R3. So as a sub relations here, which are decomposed, and functional dependencies seen here. Okay. So now I want to check whether this one is non-additive or lossless joint properties preserved or not for this particular decomposition. Same procedure. So you have to create one, okay, you have to create a new matrix. That matrix rows are what? How many relations you are having. In this, how many, in D, how many relations are there? 1, 2, 3. Then how many rows you require in this new matrix? That is 3 rows. R1 first one, R2 and R3. And number of attributes are, how many attributes there are there in this? R here. So here are the SSN, E name, P number, P name, P location and hours are the attributes of this initial matrix here. Next step 1, what it tells? First you have to initialize. What you have to initialize? First row B with symbol B, first row, first column, first row, second column. Like this you have to initialize first. First row, okay, second row, third column, second row, fourth column, second row, fifth column. In the same way, I'll take this one as a third row, first column, third row, third column, okay, and third row, sixth column. This is your initial matrix. First you have to initialize the matrix with the, okay, B symbol, and B symbol with row number and the column number. I is your row and J is your column. Like that I created the initial matrix and initialize with the B symbol here. This is your step 1 here. Step 2, what it tells? So for the R1, what are the attributes you are having? Those attribute values you have to change here. What you have to change? You have to rename or change this symbol B to symbol A here. So for that, what is the thing you have to do now? This, okay, SSN and E name are the attributes of R1. So this is your SSN and this is your E name. Then these two attribute value must be what now? A symbol and column number. This is your first column and this is your second column. So if I rename, then I got that it is A1 and A2 because these are the two attributes of R1. Same thing for the R2. What are the attributes you are having? Those attributes you have to rename as rename with the symbol A and column number. R2 P number you are renamed as A and third column P name or A4 and P location A5. So these are the three attributes of R2 here. Next, what are the attributes of R3? SSN, P number and hours. So where you are having SSN? Here. So that one you rename as A1 and P number, that is the symbol A and column number it is A3. In the CME hours that is the symbol name and the, okay, symbol as A and column number is the 6. Like this you have to rename in the step 2 here. Okay, what are the attributes you are having in the relation? So according to that you have to change the symbol from B to A here. So in the B you are taking the values as a row number and the column number. So whereas in the A you are considering only the column number. This is your step 2. Next is step 3. You have to consider the functional dependency and according to that you have to change your symbols. So what first functional dependency tells here? SSN determines E name. So SSN determines E name indicates what? In Q tuples SSN value if it is same, then E name value must be same here. So let's check. S in the first tuple and in the third tuple, that is the first row and third row, SSN value it is same here, that is the A1 and A1 here. So in any two tuples, if SSN value if it is same, then this, okay, E name value must be same because that functional dependency definition itself tells what that is the. So but here E name it is A2 and this one is not same here. Okay, E name is not same. According to the functional dependency definition, it violates, but it is already specified means what? Compulsory you have to change that value. So that's why you change this one as a A2 here according to your functional dependency. In two tuples SSN value if it is same, then E name value must be same here. It is not same, that's why you have to change the symbol from B to A here with the column number only. In the same way, next functional dependency what it is? P number determines P name and P location. In two tuples, if P number value if it is same, then in the, okay, in those two tuples P name and P location value must be same here. So here it is A4 but here it is not a value is same, then you have to rename that one as a symbol and column number here, and here also it is same, it is not same means what? You have to rename P location, you have to rename as a new symbol as a A5 here. Okay, in the same way SSN and P number hours here in two tuples. Okay, SSN and P number value. Now if I rename, so okay, in the tuples, what is the thing is it tells it is what? In two tuples SSN and P number if it is same, then you have to rename the hours also. Yes, hours it is, and the thing is what it is under A6 here. But P numbers also you have to check. Combination of SSN and the P number. Here SSN is same here, but P numbers are not same here. Okay, if it is not same, then you leave as it is. If it is same, then you have to change the hours also. These two tuples values, if it is same, then if it is not same, then you have to rename that one or change to new symbol here. But that criteria is not fulfilling here. So then you leave as it is. Okay. So now after renaming, what is the next step? According to functional dependency, step 3, you have to change the symbols here. So this is your last step. After changing that, you have to check is it there any column, okay, row contain the same symbol A here. First row, no, it doesn't contain the A symbol. Second row also doesn't contain because it contains the combination of A and B. Third row, yes, in the third row, all the symbols are A only. See here, here also A, A, and A. Yes, in this row, all the symbols are, okay, all the values contains the same symbol A here. So if it is like this, if you are get the values, then indicates what? Yes, it preserves the that non-additive join property, or you can tell this one as a lossless join property. In this way, you can check whether decomposed relations preserve the non-additive join property or lossless join property. Okay. So, is it clear now? Okay, thank you.